Hey guys, how's it going today? We got a brand new Z80 engine here, a bunch of parts for the Minarelli. We're gonna do a Minarelli build here. I'm just opening up the box, and I'm pretty excited about this engine and how we're gonna make it run from stock. Let's open this up here. There it is there. What do we got here? Carburetor, filter, and this is what we need here to start off with. Brand new Z80, 39.5 millimeter stroke. And put this away for now. Okay. There it is right there. This is what we're going to start with. Got a Z80 39.5 millimeter stroke here. Brand new Minarelli cylinder. 70cc 47 millimeter piston. Windowed. We're going to be putting on a 6cc head. Spacer plate and G2 reed intake. There, like that. Okay, we're going to go through the processes step by step. I won't get into too much detail. And I'll try to make it as simple as possible on some of the steps required to put this engine together. Okay, I got the engine on the engine stand now, courtesy of Chaos Customs from Steve Luntz. I believe Charles did this stand up for me. And what I'm going to do is I'm going to start off with marking out my ports here, my intake ports. So what I'm going to do here is I'm going to put my gasket on. Base spacer plate on. There we go. And if you see here, you're going to want to port that out. I'm going to mark it out right now. It'll be the first thing that I do. Get it sitting where I need it to be. Take a Sharpie and make sure it's fairly even, and we're just going to mark it out. Make sure that we get some good clean lines so you can see where it's at. Okay, now it's marked out. I can take this off. Take the spacer plate off. There we go. And as you can see where the lines are, that's where I need to port the case so we can port match it to spacer plate. Okay, now I got a drill gauge here just to get the right size, because this is metric. I'm going to use a standard drill bit. So I'm going to find out which hole size matches so that I can drill out the cylinder. So it's not a 1964. 5/16 fits over it nicely, but it's a little bit tight. I'm going to go with 2164 and drill out my cylinder so that the cylinder will sit onto the case. So we're going to go with 2164. Okay, we're just going to go ahead and drill all 4 holes. I'm going to run one stock base gasket, and I'm just going to check the fit after we drilled it out. Fits on nice. I'm going to go ahead and put our spacer on. Like that. Okay, I got the piston on, and I'm going to get the cylinder on here, the ring to fit. I'm having problems with for some reason. There we go. Okay, I always put a little bit of oil into the cylinder before I go at this stage. And we're going to go ahead and slip it on, just like that. And what I'm going to do is I'm going to open up the case so I can turn it, and we're going to get the squish band set up here. Okay, I went ahead and removed the cover on the coil side, and we're going to just put on, I'm just going to use one of these stock gaskets just to see where we're at with our squish. Okay, that's where we're sitting there like that, and we're gonna just see where it's at there. There's top dead center in roughly around there. So it looks pretty good. It's sitting in there with that stock base gasket, the spacer plate, and just like nothing in between there, which later on I'll fill that with silicone. So go ahead and put the head on. Let's set our torque wrench up to say 12 pounds, 10 and 12 pounds, and we'll do a crisscross pattern and tighten it up. That one went, that one, that one. Okay. Okay, we got our solder here. We got a little bit of curve into it to get the side of it. What we're going to try to do is get onto the pin. Not this way, because you could have a slight bit of rock into your piston. So I'll put that in there and turn this over. Get the squish. Okay, there it is. And we'll measure that off. Okay, after I squished my solder, we're checking it here. I'm at 0.9 already, so that's pretty good. I shouldn't have to change anything with it. With our squish band, I would say that it'll probably come up to probably 1 millimeter squish once I put in the silicone into here. And then what's going to happen is as I torque it down and put the sealer onto the main base gasket, it's going to compress down to 0.8. So I'm pretty happy with that without having to do anything at all to the squish band. So what we'll go ahead and do next is I'm going to check the port timing with a degree wheel. So the next thing we're going to do here is I'm going to put a positive stop on here. You can use anything as long as it stops the piston from hitting top dead center, and that'll be perfect. Not too low, but not too high. Okay, so we're at the stage now where we're going to check the ports on a degree wheel. I went ahead and put a stop on here. As you notice, the engine is slowly being dismantled as we're going through the process. The clutch is off now. Everything's off on this side. The clutch lever, the gears, and the degree wheel's put on, and we're ready to check our ports. So I've set up the degree wheel here. We're at 11 on this one side. You spin it all the way around, and we're at 11 on the other side, so we're even on both sides. Okay, now I can go ahead and remove the positive stop. Okay. Now, when we rotate it to the top, right there is top dead center now. We're going to move the piston downwards until the exhaust opens, just so it starts to open, which is right about there. And I'm reading 86. So my exhaust duration is times by 2 is 80, it's 86, times it by 2, it gives me 172. 172 total degrees on the exhaust duration. Okay, I'm going to rotate it downward just until the transfer opens. It's right about there, and that gives me 64 degrees. So we'll multiply that by 2, 64, my transfer duration will give me 128. Okay, I'm going to take the 172 and 128, and I'm going to subtract them from each other, which is going to give me a blowdown of 44 degrees. Then I'm going to take my 44 degrees and I'm going to divide it by 2, which will give me 22 degrees. So I'm getting a 22 degrees of blowdown. And then what I'm going to do is I'm going to take and I'm going to divide the blowdown, so 22 degrees, by the total duration of 128 degrees. 22 divided by 128 will equal about 17% blowdown. At 17% blowdown, that's not too bad. I can raise my exhaust by 1 millimeter. 1 millimeter gives me about 3 degrees on the degree wheel. So in total degrees, that'll give me 6 degrees. So if I do the math on it, so that'll bring me up to 86, 3 degrees. See, 86 plus 3 equals 89, times that by 2 equals 178. So I get an exhaust duration of 178. That's by raising the exhaust by 1 millimeter. So the exhaust is 178. My transfer stays the same, and it equals 28. 128, 28. So I'll take the 178 and I'll subtract 128, and that'll give equals 50. I'll take that 50 degrees and I'm going to divide that by 2. So I'm going to divide it by 2. It'll give me 25. Divide that by 2 equals a total of 25 degrees. Now I'm going to take my 25 degrees of blow down, and I'm going to divide that into my total transfer of 128. So divide that by 128 equal, it gives me 0.19. So that'll give me 19% blowdown, which is pretty good. I mean, the engine's going to probably be hitting about 7,000 RPM before it really starts to hit. That's the way these Minarelli cylinders kind of seem to work. Yeah, 19% is not a bad number. This thing should really really wind up, like I said, about 7,000 RPM. Okay, so I'm going to go ahead and do that. You can keep it at 17%, and it'll be hitting a little bit lower, or take it up to 19%. It all depends on where you're at. This is where this cylinder is at. A lot of the other cylinders, they have different port timings. You can decide where you're going to take yours. This one here is going to be in around 17% blowdown to 19% blowdown. Okay, I've marked my my exhaust. I'm going to move it up 1 millimeter, 3 degrees, which should bring me about 19 degrees blowdown. So I got it marked out, I got the cylinder off. Now I need to know how wide I'm going to make my exhaust port. So I'm going to take a straight edge and a marker. I'm going to take a piece of paper, and I'm going to take 33 millimeters. And I'm going to mark it right there. Okay. I've marked the center of my cylinder, so I know where that is. So I'm just going to take this little piece of paper that I marked out at 33 millimeters. And I'm going to cut it like that. Nothing fancy, just cut it like that. I'm going to take it now, and I'm going to try to fold it in half. Okay. So there, now I've folded it in half. And I got a center mark there. I can mark that on that piece of paper, the center, okay? Now I want to take that and want to move it slightly into a curved. What I'm going to do is I'm going to lay it down here, like this, right up against the edge. Put that center, and I'm going to mark it right here. And I'm going to mark it right here. Okay? That gives me 33 millimeters off center. Right? Once I've done that, then I can take my straight edge with the flat side down and put it into my cylinder. And I can line it up with that mark, and I can run a straight edge up. Okay? Go to the other side, do the same thing, and run it straight up. Make sure I got a good mark. All right. So that there is just giving me 33 millimeters wide at, on the degree wheel. I moved the exhaust up by 1 millimeter, 3 degrees. In total, it's 6 degrees from total exhaust duration. Okay, which is going to head me up to, I think, is about in around 19 degrees blowdown. Okay, so that's going to be part of my porting that's started out. My transfers, I'm not going to do anything to them, but slightly clean them up a little bit. They really don't need a whole heck of a lot. I'm going to go ahead and I'm going to open this up. So I'm going to take this straight edge and I'm going to mark it along here, just roughly off the straight part of that, and I'm going to mark it here, and I'm going to come on to the other side and I'm going to mark a straight edge up here, and this needs to be opened up, right? So I'm going to roughly open it up depending on where my this will sit here. So what I'm trying to do is, this is now being blocked by the spacer, and it's about that thick, and it's hitting the top there, so I need to move it up at least the thickness of the spacer. So at the bottom, roughly about, I can measure it with the, a little bit difficult to do it like, there we go. It's going to be roughly up to about there is what I'm going to take it up to. So I'm going to mark out a rough line here for me to guide it to. It's going to curve slightly, just like the bottom one. It's not a very good line, but you get the idea. So I'm going to open this up that, it probably a little bit less than that. I don't think I'm going to go quite that high to leave a little bit of material here. So that's just like a rough draft drawing there. Okay, so now with this spacer being on here like this, what happens is the fuel is going to be shooting up through here from our transfers into our transfers, from our case up into our transfers. Well, this whole area here is now creating a dam. Okay, so what I'm going to do is I'm going to remove all of this on each side, and I'm going to knife edge it. So I'm going to take this down here all the way down to the bottom, so I get a straight edge off of there, right off the transfer, and straight up like this and like that. Okay, I'm going to remove all of this material all the way down to here, and I'm going to create a knife edge from here, so the fuel will now not dam anymore. It'll just go directly into the ports. I'll do the same to both sides. There. And there. Okay. So we'll remove this area here and this area here, and we'll be removing this. Okay, so we get better fuel flow up through the cylinder because of the spacer now that we've made and put in place. Okay, as I widen out my exhaust and bring it up to 1 millimeter to get my 19% blow down, like I said, removing the sides for the transfer for the damming and off my third port. I'm going to also have to open up my front of my exhaust here, so I marked it out here, and I'm going to remove that there and opening it on the sides. When I'm porting this, when you're porting anything, go slow. You can never get back what you remove, so take your time when you're removing material from the cylinders, because once you go past that point, you go past it. So that's all I can say about that, is just take your time with it. Okay, I'm going to go ahead and start pouring this. Okay, now that we've completed porting the cylinder, it's opened up quite large here. I've removed the sides and knife edged it, if you can see here. Nice knife edge. Also, the exhaust port has been opened up to 33 millimeters, nice and wide. And I've also taken the edge off all of the surfaces that I worked. This has also been opened up quite a bit. So now I got the engine here. Before I take the engine apart, which I'm going to do next, the case, I laid the plate onto the gasket, and what I did was I took a marker and marked it out just like I marked out the case prior, so that we can do the port matching. So now my gasket's all ready to go, and my case is all ready to go, ready to pour it out, and my gasket is, so I can cut it out. Okay, so if we take a look at our plate now, it's quite a bit opened up like originally it was on the bottom here for the third port. The sides have been reduced down. There's no more damming in these areas, with a nice knife edge. So that should allow really good fuel flow up into those transfers without it damming. Okay, so that cylinder's all ready, cleaned up, ready to go. And now what we're going to do is we're going to install the G2 block onto here. Okay, we're going to start off with some aviation forma gasket. We're going to paste a little bit of this onto the gaskets, get it on. Nice even coat. And this can be a little bit messy, but it'll work quite well. One side and do the other side. And there we go. That's better. Okay. So that's covered. And what I'm going to do is this too. I just want to talk about this block, this reed block. This has all been upgraded to 6mm bolts, drilled, tapped. Same with the intakes I make. They're welded with a B pressure welder here in the shop, a local shop here. The surfaces are all ground flat and ported out, and they're also opened up to take a 6mm bolt. That way when you go to tighten them down, I find if you just leave the other bolts, they tend to want to strip on you. So I'm just going to take this, can be, like I said, a little bit messy. Put it on here. All these surfaces have been ground flat as well. Take this, put it into my adapter block, and tighten it up. Before it gets tightened down, I'm going to even it out to make sure that's nice and even on both sides. It's fairly good. And then go ahead and tighten it up. Anything that squishes out though, you can clean up later. I usually use acetone to clean it up. It works quite well. So this has your lockdown, your washers, and your lockdown nuts to make sure that it doesn't get loose. Just keep tightening back and forth. And then what I'll do is I'll take a wrench, put it on there, and really tighten it up. Okay, that's pretty tight. Okay, so now that's ready to go into here. So what I'm going to do is prepare this area so I can put it onto the cylinder. So what I got here is Ultimate Gray gasket maker, and this is a high temperature gasket maker. And I'll take a brush like this, and all I want to do is coat the area where the block's going to be. In here like this. Not down in here where the port is. Kind of like that. Just get it into the corners there. And then I'll paint the outer edge like so. And you want to make sure you get a good, a nice even layer, I would say. It doesn't have to be really thick. It just has to be a nice even layer, but enough to seal it. Okay, that area is prepared, and I'll just put a little bit on here, a little bit on this side here. Okay. That's where the mating surfaces are. And I'll wipe it, any excess I'll just wipe off after I've sealed it. Okay. All right, so that's been coated. The inside's been coated, the edge has been coated. So I'll go ahead and put it into there, and just gonna get this to sit there like that for now. So I'm gonna take this with a washer and a lock nut washer, and sometimes you have to pull this out a little bit because of the length of the bolt on the top edge part. Okay, so I'll install that one there, that one there. Now I'm gonna have to pull this out a little bit and start these bolts off. Make sure they're threading in by hand before you go ahead and start wrenching on it. There, now it's nicely going in there. All right, keep going down nice and even. Just till it's just slightly snug, not too tight. Okay, so that part's done. Like I said, it can get a little bit messy, but we would definitely want a good seal. Lock nut, and then the washer. All right, then you can put in these ones starting by hand. Another one goes. You just have to pass this little ridge here. I'll go ahead and tighten that up. So it's starting to see a little bit of squish out everywhere. Okay, go around, start tightening it up. I just watch the lock washer to watch it go down so it's flat. Not over tightening it, just getting the lock washers to sit flat. Okay, there, there, over there. All right, so that's just snugged in there. The reason I'm doing that is because there's a lot. I don't want to squish out all my gasket maker right off the bat, so I'm going to let that set up now for probably overnight, and then I'll go back and I'll retorque them all down. Like I can go ahead and wipe down any excess squish out that's there. I'll just clean it all up. I'll continue with this until I get it all off, and then I'll go up and I'll clean up that with the acetone. Okay, so I'll clean that up after. And if you can see here, I don't know if you can see there, inside there is just a really nice direct flow into the cylinder, and all that space has been taken up, so there's no extra volume. Okay, like I said, comes in my kit is some G2 reed stuffers that I'll stuff in the side. But we're going to go back now to the gasket maker, aviation gasket maker, and I'm going to cover the gaskets. Right. It's really important to make sure that you really get a good seal here. So I'm just going to paint these up. Get a good coating on them. like that. And the other one is good. Just say coat it. That one there for now. To the other one. These gaskets too that come in my kit, I hand make them out of a paper gasket material. I don't use the ones that come with the G2 because they tend to swell. These ones don't. And like I said, it is a little bit messy. Alright, get close here. So we're going to layer this together. So what we're going to do, so this stuff is sticky, really sticky. Okay, so now, let's see if I can get this on some here. Maybe I'll use this. This looks good. Use that for now. Okay, so I'm going to put my stuffing plates in there. 2 on one side, 2 on the other. Like that. Okay. Take this. That's been. Take my gasket and I'll lay it on here. Okay. If you feel the need to, you can also take a little bit of this and just tap it on here. The extra won't hurt it, that's for sure. Okay. Looks pretty good, even all the way across. And my plates have fell down. Okay. Okay. I'll take my reed here and I'll stick it in there like that. And what I need to do is just get them to fall down like that and they will close up. Close right up. Okay. Okay, so that's layered there. Then I'm going to take this and put it on top here. Okay. Then I'm going to take my intake and lay it on top of that. Trying to keep it all fairly even. Alright, so my 6mm bolts with washer. And a locking nut. I'm just going to go ahead and put them in by hand. Get them started by hand. Make sure that they're started. We'll start it. Right. And we'll go ahead and just tighten these up a little bit. All right, one more here. Coming on over, we're gonna tighten this up right now. I'm gonna just get some of it to squish out. Just like medium tight, I guess. Probably like I would say maybe like 5 pounds is on there. And that's it. The cylinders all put together. It needs to be cleaned up, wiped down. I'm going to use some acetone and get it looking all nice and clean. Get all of it, the silicone, extra silicone off. So that's it. That's cylinders ready to go on to the case as soon as we take this and we pour it out the cylinder, fix the gasket. Like I said, once it's apart, I'm going to get at the crank. I'm going to balance the crank, and then we're going to take this clutch out and we're going to put an SAF super clutch into it. And I'm going to be running 700-pound springs on this one. Okay, with the magic of video, this is all dry now, cleaned up. And tightened. So I retorqued all these things. They're really tight now. It's going to be a really good airtight seal. Okay, so that's the finishing off the top part of the engine. That's ready to assemble, and I've pulled apart the case. So I pulled apart the case now, which what was left to take apart. I got my port marks here for port matching the case, and I'm just going to go ahead and we're going to grind out at a 30-degree angle, just a small amount to match up to the spacer plate. Over here I have the crank. The crank's in my stand here. If you look at it, this is just pulled out of the engine. I believe that's probably about a 5/1000 run out on the shaft, and we're going to go ahead and balance this crank and get it to run true, or as true as I can get it to run. Okay, I got a die grinder here. Some guys use Dremel tools. I prefer a die grinder. It has a aluminum cutting tip on it, single blade instead of the crisscross pattern. Works better for aluminum, doesn't get as gummed up. So let's go ahead and start porting this. Okay, I'm all finished porting out this side of the case now, and I've only taken out just a minimal amount. I tried to keep it at a 30-degree angle, 25 to 30-degree angle, just so I'm not reducing or taking too much material out of the case, to keep the volume in the case. So at this point here, I got case stuffing plates. If I was going to stuff this case now, I would go ahead and install the plates and JB weld them in there and let them sit for about 24 hours or 12 hours at least anyways to dry. But this engine here is not going to get stuffed, but I just thought I would show that. These do have a right way and a wrong way to, this is the right way to go on. It lines up with the ports, and if you flipped it around and put it in, it would be off on your port. Okay, so some people put them in there like that and then they go, oh Doris, they don't fit, but I just tell them to flip it over and they put it in there. It lines right up with the port. Okay, so anyway, so that's case stuffing plates, in case anybody's interested. They're on my website. All right, so that's it. Minimal amount to make it transfer the fuel. All right. Okay, I'm going to go ahead now and finish off doing this one. Finish off porting out this one, and once that's done, I'm going to give it a quick polish and I'm going to move on to the crank. All right, the case is all finished being port matched on the transfers. You look closely. I only removed like 25 to 30 degree angle. I left lots of room here, 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 and here, so that I get a really good seal. I also ported out for the third transfer, leaving lots of room. We got a pretty good transfer up of fuel, a really nice angle up into the transfers into the cylinder. Okay, so I'm ready to put this back together, and we're going to start on the crank. Okay, so we have our crank here. I'm just going to show you how much I just pulled this out of the engine. It's a 39.5 millimeter stroke ZA80 crank. I did put a 120 emery cloth on here and finished it off with a little bit of 240 just to polish that down a little bit, because these are way too tight. Some guys say heat them and then freeze them and put them together. I don't think, but anyways, so it goes on nice and smooth all the way up through here, and then at the last little bit it's tight. Okay, that's the way I like them. That way when you put the case back in together, it does not compress this in any way to change the truing of the crank. So I'm going to go ahead and put this into my holder here, and we're going to set it onto here, and let's see. We're going to zero this off roughly on here. Okay, let's just spin this around, and we have run out both ways. I've got 2 thou. We'll start this here. There, that's better. So right at where the crank pin is, what that's telling me is I turn it around, and this side of the crank is lifting up like this, and and it's on a wobble for the and so this part of the crank right here is squished in and causing this part to come up. So this needs to be spread apart here. So we're at 0 there on this side. And I'm right factory, I'm 5 thousandths out. It's got a 5,000 run out. So that's substantially making that crank wobble, and especially this engine is going to probably hit 12,000 RPM, and that's going to make it vibrate like crazy at a 5,000 run out. Okay, we're going to try to correct that, and we're going to balance it. Okay, that's what one side. We're going to turn this around and put it onto the other side. Okay. All right, I'm going to 0 this gauge. I'm going to move my pin up. I'm going to get it 0. All right. So as I rotate it this way, I'm doing the same thing. So at the pin, we're at 0. I'm running it up into the middle of it. The pin's on the bottom. I'm at 4 thousandths because it's not quite zeroed. So I'm about 4 thousandths run out, and it's in the same way. So that crank is basically like this, and it's wobbling like that. So these need to be spread to bring them down again. I suspect when the engine was put together, because these things were so tight, that when the pressure of the case pushed onto the sides of this, it compressed this in slightly inward like this. The pin's not going to move, but this will, you know, because as much pressure as you put onto that, you're not going to move that. But at this point, it's delicate, and you can throw it out and get a run out like that. So I fixed the problem by taking these down a little bit so the bearings fit on properly, and I'm going to go ahead and true it, and I'll show you the difference when it's trued, and I'm going to balance it. So I'm going to get ready to mark it for balancing. Okay, what I've gone ahead and done is I marked my points, measured it, marked it with a caliper evenly here, and my widths. Now there is calculations to figure out balance factor for balancing your piston and that. I'm going to go ahead and remove the weight that I need to reach 11 to 12,000 RPM with the piston at a certain percentage or rotational mass. You can decide what you want for your piston, your weight of your piston. There's a lot of variables, so you pretty much need to do your own calculations and come up with the numbers you need. So I'm not going to pull this this clutch apart off the pin. So to protect the bearing here, I've put paper towel in here, like a shop paper towel, into the gap, protected the bearing, and filled it with paper towel here and here and here, and then taped it up. So that'll protect it from getting any shavings in there, so I can go ahead and do the work. Okay, I got the crank into the drill press. I've marked out my marks that I'm going to drill. I've done the balance factor. I'm going to try for 60% over rotational mass, and I got a pilot bit in here to start it to guide the larger bit. It'll help it out so that I get a straighter drill. Okay, now I'm going to drill out one of the larger holes now using my pilot bit. Okay, I've finished drilling all the holes to balance the crank to my piston for the rotational mass. Now what we're going to do is I'm going to true it. So we're going to try to get this so that it's not, doesn't have a run out of 4 thousandths. Okay, I've trued it as close as I'm going to get. It's within 1 thou of run out. And that's close. That's more than, that's like a hair off, and I'm good with that. So that's it. That's trued and balanced crank. Okay, we're going to move on to I think that's about it. We can start putting the engine together. Alright, so I went ahead and reassembled most of the engine, well, part of it anyways, got in the crank. It's flowing nice and freely in there. It's balanced, trued. I put on the cover on this side, put the gear back on. So now, and I also installed the clutch shaft back in. Now, I'm setting it up for the SAF super clutch. So it's just the shaft. I covered the hole and put the bearings back in. I also cleaned up these a bit with some emery cloth so that the bearings go on quite easily. They go up to about 1/4 of an inch and then they snap in place, and that way they're set on there. Find that when they do these, they don't take the time to clean these up very well, so the bearings are forced on, and they shouldn't be forced. So, and the same with the shaft on the crank, I did that as well. Okay, now that we've got that part done, I'm going to go ahead and I cut the slot for the flower nut, or the locking nut for the SAF super clutch. And we're about to cut the plate for the clutch as well. So what I got here is a hole saw, Milwaukee hole dozer. It's quite a good hole saw, 3.5 inches, and that's what I'm going to use to cut the hole. On the cover itself, a lot of them have this small little circle in the center. That's what I drill off of. I mark the center of that and then I punch it, and then it'll give me a line up when I go to drill it. Okay, I've gone ahead and I've clamped it down, got it center and ready to drill. Okay, so we're going to put the cylinder head on and torque down. So I'm going to paint this with aviation gasket maker. Okay, that's sitting on there pretty good. I'm going to coat the cylinder. Okay, so I got a nice coating on there of gasket maker. I'm just adding a little bit of oil inside the cylinder to make it take the piston a little bit easier and give it a little bit of lubrication while it's just before it's run. You're going to take your time with that gasket maker on there. When you put this on, there we go. On there, it looks really good. I like to use a long screwdriver, thin small one, to get the washers on. And then the acorn nuts. Now I'm just going to let it dry overnight like that before I do the final torque. Alright, so now it's getting pretty close to being fully done. So now I'm just got the clutch to put on. So I'm going to go ahead and fix up the basket, tap it, get it on here. And I'll get this gear on, and always make sure that these bearings are nice and free after you install them. You get the basket on, tap it, and we'll go ahead and get the gear on the other side, like I said, and then we'll install our clutch onto it, and we'll adjust the bucking bar. So with these green springs on the SAF Super Clutch, because of the difference in pad size guys use and the thickness of it, they need to be reduced down. These ones are going to be the stock pads that I'm putting on there. So this I'm going to have to take down as 20.5 millimeters in length, and I'm going to take it down to 18.6. Alright, we got the clutch basket installed, the gear on the back installed, the drive gear, flower nut rod it's been cut, slotted so that we can do fine adjustments. Tighten this in all the way. And take the locking nut and put it on there. And we'll tighten that up all the way. Oops. Just so it's snug. All right. Install it into the. Take our springs. The springs been out, or because we have the stock pads. And then we're using the heavy duty 700-pound green springs. We reduced it to 18.6 millimeters to be able to give the 1.5 millimeters it requires to release the clutch. When the clutch gets pushed this way, the spring compresses even more, so you need at least 1.5 millimeters to be able to release it. For these shoulder bolts that I have in my clutch, I use a 532 because they're standard Allen shoulder bolts, and it uses a standard 532. Don't use metric on these, you'll strip them out. So I'm just going to get it so the springs are touching and putting slight pressure onto the disc. I'm going to go ahead and put some grease into it. Okay, we got the clutch all installed, the bucking bar in, and what I do is I upgrade this to an Allen head instead of the Phillips screw. I'm just going to give you an example of how hard this clutch is, like how much pressure there is there. That's 700 pounds on this thing, and to push it in, I'm pretty strong. I have to hold the engine like that, put my hand against that bar and push it in. That's how much pressure there's there to release it. Yeah, it grabs. So here's the cover I cut. All we got left pretty much is to put this cover on, and the engine's pretty much complete. So we'll go ahead and throw this on, finish it off. Alright, that's that. 70cc Minarelli. Ported out G2 reed SAF super clutch. I hope you enjoyed watching me build this engine. It's going to a customer. I'm sure he's going to love it. I can't wait to see videos of him running it. I just want to give a reminder with these engines. These engines are putting out a lot of horsepower now. These engines are race engines, intended for track only. Wear your gear, wear a helmet, wear some gloves, boots, jacket, pants, protect yourself. Okay, so now that the engine's all together, checked over everything, the final thing I'm going to check now is the squish. And I'm going to take a little bit of solder and put it into the top here on the side of the pin. And we're going to turn it over. And let's check to see what we ended up with. And we're in around where I said it was going to be, around 8. Okay, that's perfect. So now I just want to do a recap on everything that we did with this engine. There was a lot of things that we did to it. So just to recap it all, I had to write it down because there's so many things. So anyways, this case is the Z80 39.5 millimeter stroke. We put onto it a 70cc Minarelli vertical 47 millimeter piston, your iron cast Minarelli. It's got the spacer on it with the G2 reed conversion kit that I built. We trued and balanced the crank. It's at 60% over rotational mass. We ported the cylinder at the exhaust was at 178, 34 millimeters wide. The transfer is at 128, which equals about a 19% blowdown. Targeted RPM is about 12K. The case was port matched at a 25-degree angle to the spacer to not remove too much volume in the case. The transfers were lowered on the side where we removed it because of the damming that was happening with the spacer, and we knifed it, so we put a knife edge onto it. The third transfer was opened up to match the spacer as well, for optimal fuel flow. We got a 6cc head on here. The squish band ended up to be a 0.8, and it was torqued down to 14 pounds. The G2 reed has been upgraded to a 6 millimeter bolt. It's got reed stuffing plates inside it with a VM18 machined flat pressure welded intake. We put on it an SAF super clutch, 700-pound springs, and the springs on stock pads have been ground down to 18.6 millimeters. So that's pretty much everything I did to this engine. Just a recap on everything. Like I said, this clutch has got some crazy pressure on it, 700 pounds. This thing should be a good runner. Turning it over, it has huge amount of compression. And then finally, I just want to give a shout out to a few guys who's helped me along the way with this hobby. Ethan Smolik, Kirk Smolik, Chris Sly Larson, Steve Lentz, Charles Lentz, Ryan Kellett, Kelly Counselor, Ken Henson, and Ryan Durag. Just I want to thank you for all the support, all the R&D that you guys helped me with, and thanks for improving the hobby. And that's it, man. Thanks. Okay, so I thought I'd just talk a bit about my buggy here. I'm sure I'm going to get a few questions on it being in the video. This is a 1969 VW Baja. It's got fiberglass hood, fiberglass fenders, fiberglass seats in it. The interior's been completely stripped out of it. It's got a full roll cage in it, 4-foot Fox racing shocks right up in through to the suspension. What else has got in it? All aluminum panels on the inside, so it's like super light. I can just push this thing around. It's so light by hand. It's got a 2300cc dual carb engine in it. It's fun to drive. I get a lot of attention when I drive it around. It's fast. It's got a 1969 bus transmission in it to help out with the bigger tires on it. It gives it a lower gear ratio in the rear. This thing, just an example, you can pop the front tires off the ground, and if you were to race a Mustang GT off the line, you'd easily take it. You wouldn't beat it in the long run, but you'd beat it across the lights. But that's my 1969 VW Baja. The body's also been lifted off the pan 6 inches to raise it up. That's what you do with these. Yeah, definitely a fun car.